Hey everyone, this is Evgeny and you're watching next episode in LangGraph Advanced series. Today we're gonna check how you can construct supervisor architecture using tooling. So join me and let's take a look at that together. But before we dive in, I wanted to mention that this video is extremely highly supervised by angry cats. If you're curious, what are those? Well, check the link below, the merge is there. Today we're talking about another way how you can construct your supervisor architecture, and before we dive into the tooling, let's first give it a try the way how we already implemented it in the past. So I'm compiling several graphs here, and those are research agent, and then I have trading agent as well as the tools, and finally we created supervisor using the high-level API from LangGraph, and that was create supervisor, and here we provided list of agents. And so we have this kind of supervisor architecture where two agents, research and trading, are under control of supervisor. And this is something we saw it in the past, and it's pretty simple, pretty simple architecture to implement, but there are a lot of different ideas behind that, and let's give it a try and run it so we see how the whole conversation happens here. And if we check the messages thread we get after the supervisor run, let's take a look at that together. So we have a human message as a request. Then supervisor decided to make a tool call for current timestamp. And what else significant happened here? It was a transfer to research agent, and then this one performed web search tool call for promising AI companies, some results back, and another wiki search as well. So research agent gathered some data and then transferred back to supervisor, and then supervisor decided to move to trading agent. So pretty standard picture, we saw it multiple times already, right? And the bigger drawback here, or maybe not drawback, but something you have to think about all the time, that this is a shareable list of messages. So when the supervisor provides control to an agent, for example, to research one, the research agent can see the whole conversation happen before that. And it can be plus, like it might give the research agent more information about what's happening. It might help it to understand better the idea, what should be done, what kind of result is expected from it, right? But at the same time, it can be confusing. Just also imagine you have really extremely big AI agent, and then the work itself lasts for some time. Then you have really huge channel where everyone talking about something, right? And this can be confusing. So one idea, you might want to restrict it. So for example, have a research agent, and well, we saw it in the previous lessons. Maybe the idea would be that the supervisor provides a task, descriptive task, what should be done, but does not confuse with the REST messages. So this is one drawback here. And another drawback, if you have multiple agents and it takes time to perform the job, and it's a bit tricky here, how would you run the several agents in parallel and just to make everything faster, right? It's not clear here because, well, they're sharing the same channel, and well, practically you have to do this the map reduce thing, and then it's a big question, how would you reduce back the messages from several agents? So it's really a bit tricky to implement this kind of architecture here with using the standard classical approach. And there is another way I wanted to show you how you can organize the same system, but removing all these drawbacks I just mentioned. And this is supervisor-as tooling. It's kind of another architecture. It's the same idea, it's supervising, but it's a bit different implementation here. So how would it work? Let me show it to you. In general, the raw idea is pretty simple. What we are doing, we are saying that our every agent is a tool. So supervisor at the end of the day doesn't have any sub-agents under the control, but it has a number of tools, and supervisor can perform some specific job knowing which tool to use, right? Which area of responsibility tool can cover. So this is how it looks like. I'm defining a new tool, and this one is the research agent tool. And here what's happening, first of all, I'm defining the Docker string, so it's clear for the LLM, for the model, one way, when and how the tool can be used. And here I have this research agent, and I'm doing just invocation, providing the single message, which is a task. And task comes from the parameters. Here is a string. And in the description, I'm also describing that the task is expected. It's a clear research objective, which should come from supervisor, right? And also, I'm providing config as well, right? And this one is from runnable config, and this one is from LangChain core runnable. And also, I'm not using it here, but also you can inject state, current state. Like I mentioned that, okay, we are not sharing, we are trying not to share the message thread, the channel, but in general, if you have a very specific state, if you have some variables there, which might be helpful for this agent to work, you can take the state as well, right? But we are not using it, I'm just showing to you that it's possible. And what's happening, we are starting the new thread, the list of messages is empty, so it's fully isolated run. And the first message is the task itself from the supervisor. And then finally, we are returning result back. And here we are just grabbing the last EI message from the agent and providing it back as a response, right? So keeping all the job hidden from supervisor. And we're doing the same for trading tool. So there's a trading agent tool, the same kind of task, state as well, and configuration. I'm providing Docker string. Absolutely the same. I'm just doing the invocation of trading agent and providing back the latest message from this agent to supervisor. Okay, and then my supervisor is pretty simple. It's not a supervisor anymore, kind of. It's just a normal agent. So I do have a system message. I'm still providing some external tools like get current timestamp. And here I'm just creating a React agent using this high-level API. So I'm defining the model, I'm defining a list of tools, and look at that. I have current timestamp, I have a research agent tool and trading agent tool as well here. And practically that's it, right? So I have a single agent and number of tools which it can use. The same classical view of React agent, and now we can give it a try and run it with exactly the same request and see the differences here. All right, and let's take a look what we have here. Please ignore all these warnings. It doesn't relate to the lesson I'm showing to you, but in general, in production, you have to do something with that. Probably some simultaneous tickers were delisted. I don't know why. We don't spend much time on that today. So what do we have here? We have a human message request, and then supervisor made a tool call for current timestamp. It's there, we can see it. Then supervisor decided to make call to research agent tool providing the task. So find a leading AI company for investment. And then everything in the rest is hidden from us kind of, but we have the single message as a response back from from the research agent tool. It's a tool message. And based on research, it thinks that, okay, Microsoft is a good opportunity to buy, right? And then supervisor made another call for trading agent tool. And this time task is buy 1,000 worth of Microsoft stock. And then trading agent again performed something under the hood. We don't know what. We only have the latest, the tool message as a response. And here the trading agent tool reported that our order to buy 1 share of Microsoft has been successfully finished at the specific limit price. And practically then we have the final report from supervisor reporting that, okay, I researched, like it was a research on the AI sector. We found that Microsoft is a good candidate. We invested to Microsoft for 1 share with a limit price of 500 something, and practically that's it. So you see the difference immediately, right? First of all, the message channel was not used by the tools. It was completely ignored. They worked in isolation, and we're not putting it here. So every tool had a very clear task, what should be done here, right? And another really big plus here, it's much easier if you want to make it parallel. So each agent now is a tool, right? And it's much easier to run them in parallel. So you can do it. And finally, like the number one thing, it's in isolation. So you don't have any problems with sharing data, sharing variables, like confusing each other, etc. So this is just another type of supervisor architecture with tooling. All right, this is the end of the video, and I really appreciate you sticking with me till the end. I hope you found something interesting and you've learned something new about LangGraph and architecture, the AI agents. And it was me, Evgeny. I will see you next time in the next video where we are going to talk about LangGraph. See you and take care. Bye-bye.